Assalamualaikum. Welcome to our short tutorial on the heating curve. This is the objective which is given under the chemistry O level syllabus, and we are going to talk in detail only about the heating curve for this tutorial. In simpler terms, heating curve is a graphic representation of temperature against time, which is drawn as any substance is heated over time. So for this, we are going to take the simplest example, which is of water. And I will assume that we take a block of ice, which is solid water, from the refrigerator, and we are going to keep it on a stove and turn on the flame. So the moment we turn on the flame, we start the time and we start recording the temperature. So now that we turn on the flame, the heat energy is being given to the solid ice, and that heat energy is being converted into kinetic energy of the particles. So the particles present in the solid start vibrating more and more and more. So as they continue to vibrate more, they are gaining the kinetic energy, and therefore the temperature rises. This is an important law of physics that as the kinetic energy increases of the particles inside the matter, so subsequently the temperature rises too. So therefore, as the kinetic energy is increasing, the temperature is rising until the freezing point is reached. At the freezing point, now the heat energy being given to the particles is not being converted to kinetic energy. Instead, the heat energy is being used to break down the intermolecular forces of attraction during the melting point. So now the forces of attraction will be broken down, which convert that solid into liquid. There is no rise in kinetic energy over here. So therefore, no rise in temperature occurs during melting, and the temperature remains constant or steady. At this point, all the solid is being converted into liquid water, and now, as the change of state has occurred, the liquid particles start gaining the kinetic energy. They begin moving faster and faster and sliding past each other fast. So the heat energy now is being converted to kinetic energy, and therefore there is a temperature rise throughout the time that the liquid gets heated up. As the boiling point is reached, again there is the time for the change of state. Now again, no longer the heat energy is being converted to kinetic energy. Now the heat energy is being used instead to break down the intermolecular forces of attraction. So there's no gain in kinetic energy, so no rise in temperature, and therefore the temperature remains constant or steady throughout the process of boiling. The is being converted to gas during this time. At this point, all the liquid is converted to gas, so the change of state has ended. Now, as the forces of attraction have ended up, now the gas particles can again use that heat energy to be converted to kinetic energy, and therefore the gas particles start moving fast and fast here and there. So they continue to gain the kinetic energy and the temperature continues to rise. Now we are going to label this graph. Okay, so now the graph is labeled. I want to highlight a few important points that as you can see that the time taken for the boiling is much greater than the time taken for the melting. Now, this is due to the fact that during the process of boiling, a greater amounts of the force of attraction are actually overcome in the conversion from liquid to gas. However, there is lesser amount of the forces of attraction which need to be overcome in order to convert solid to liquid. So therefore, more heat energy is required during boiling than during melting. And this more heat energy is provided over a longer period of time during boiling. So therefore, boiling takes longer than the melting. Another important point that you can see that the boiling point and the melting point are sharp and they are actually constant. If any impurity is present in the substance, in our case, if there's any impurity in the water, so therefore the boiling and the melting point would be different than this 0 and 100, and the graph won't be actually flat, it would be at a slope, right? uh, the boiling and the melting points won't be sharp, and on the graph the presentation would be as slope. Also, if you see, this is now the cooling curve. You should know that the cooling curve is exactly the mirror image of the heating curve. Over here there was melting and boiling, and over here the exact opposite thing, that is here would be freezing and here is condensation. The heating curve is like a step up graph, that is the steps are going upwards, and over here the steps are going downwards. Now we'll move to a short quick MCQ. So that is an MCQ. You can stop the video for 1 minute and read it on. Okay, so the important points in this MCQ are there is a melting point of 69 degrees Celsius. This substance is being cooled down, and the question says that what process occurs between 8 and 12 minutes. So whenever there is a graphic question, I would suggest that you take a pencil and mark down the readings which are important. For instance, it's saying that the melting point is 69 and it is asking which process occurs between 8 and 12 minutes. So 8 would be somewhere here and 12 over here. So you can uh, mark them with a pencil. And now, so it is asking about this part of the graph. Now, read the question carefully. You should not be overconfident that they are giving you the melting point so that you mark melting straight away. Just pay attention that the substance is being cooled down and not heated up, and the graph is a step down graph, that is a cooling curve, which is a mirror image of the heating curve. If this was a heating curve instead, so at the melting point, the melting is happening. As this is a mirror image, that is a cooling curve. So what would be happen is the opposite of melting. Melting is moving from solid to liquid, that is melting. This is the mirror image, that is moving from liquid to solid, which is the opposite of melting, and that is freezing. Moving from solid to liquid is freezing. So the answer in this case would be freezing. So that's it from the short tutorial. Thank you.